Here goes a volume of composite figures video. These shapes probably look a little bit similar to you if you watched the video on surface area of composite figures. Really the only thing I did was change this example to have an inside or actual height of a pyramid of 5. Because for volume of a pyramid you need inside height, not the slanted height. And the purpose of this video is not to trick you with finding missing pieces, it's just how do you use it. So, nice thing about finding the volume of composite figures is it's quite a bit easier than finding the surface area of composite figures. Because you have to remember, when you're finding surface area, you actually have to decide how many bases are exposed, what kind of lateral areas are you going to find, are you going to add this, are you going to subtract this. Volume is much easier. To be honest with you, all you have to do is find the volume of each figure and add it together. Because what you have to remember is volume is actually filling up the entire space. It's not just painting the exterior. So this is like we cut a hole in the top and we're going to fill this thing up with water. It's just going to first start and fill up the prism. And then once you get to the top of the prism, it's just going to start filling up the pyramid. So really, volume is filling something up, so you just have to find the volume of the pyramid, and you have to find the volume of the prism, and you just have to add those two numbers together, and you're done. So check it out. To find the volume of a prism, you just need to find the base area, multiply it by the height. So our base area is 6 by 6, so it's 36 times the height of 10. The volume of the prism is 360 units cubed. And then once we get to the pyramid, remember the formula changes just slightly. The volume of a pyramid is 1/3 of the base area times the height. So we have 1/3 of our same base area of 36 times the height of 5. And that's going to end up giving us 60 units cubed. So what's the volume of this stack right here? 420 units cubed. And you're done. In our paper towel roll example, we're going to be finding the volume of just the paper towels, not as if this was a full cylinder. Because remember, if you think of a roll of paper towels, you have all the paper towels as one big cylinder, but then you also have the cardboard tube and all the space in the middle. So this is an example of where we're going to find the volume of an entire cylinder, but then we're going to subtract the volume of the cardboard tube. So let's give it a try. First thing you want to do is find the volume of the entire cylinder as if it was one piece. So to find the volume of a cylinder, it's radius squared pi for your circle base times the height. So the radius of the big circle is going to be a total of 6 because we have the 2 for the inside plus the 4 from here to here. So we have 6 squared pi times our height of 10, giving us a total volume of 360 pi for the entire cylinder. But now we have to subtract all the space that was taken away when we removed the middle, or the space where the cardboard tube goes to hold all the paper towels. So that has a radius of 2 squared pi times the same height as the paper towels, which is 10, and that's going to give us a total of 40 pi units cubed. And of course, to find the total volume of this shape, all you have to do is subtract the 2 now, because we're taking volume away by using that tube. So we're just going to subtract those 2, and you end up with 320 pi units cubed. And that's it for volume of composite figures. This is Longo, and I'm out. See you, bye.